Hi, my name is Gaurav Sharma. I'm from the Vision Systems Product Marketing Group. This video is an introduction to scripting for the Insight Vision Systems. Now, the goal of this presentation is to prepare you to have a high-level conversation about scripting. So it does not go into great technical details about scripting. I'll basically cover that in other e-schools. The intent here is to give you a sense of three broad things. One is the class of problems that scripting can help address. The second is the benefits that customers can derive from scripting. And finally, I'll talk about some of the features that are available to users in this release. So what will we cover in this video? We'll talk about the Insight Vision Systems that support scripting today. One of the things to note is that not every Insight Vision System actually supports scripting today. We'll talk about target users. Then I'll go over problems that scripting can solve and some of the benefits customers can derive. And finally, I'll highlight a few of the scripting features and the capabilities that are available on Insight platform. And then finally, I'll point you to some of the resources that you can use to learn about JavaScript and more specifically scripting capabilities on Insight cameras. So when we talk about scripting for Insight Vision Systems, we're really talking about two components. The first is the spreadsheet part. There are a couple of functions to support scripting. There are the results that scripts generate that the spreadsheet consumes. And there is the sort of more sexier part, basically the JavaScript and the JavaScript functions to access data from Insight Vision tools. Now, I mentioned JavaScript. So JavaScript is the language we use to support scripting. We use a fully featured standards-based distribution of JavaScript. The engine we use has a very small footprint, memory footprint, and is just perfect for what we actually want to do on the Insight Vision Systems. So it is not just the JavaScript functions for data access from Vision tools. You also get the full-featured JavaScript language to go along with it to basically build some really powerful Vision applications. What I would also like you to note is that JavaScript is not related to Java programming language. And in fact, the only connection between them today is that Oracle Corporation owns both the trademarks. And there is absolutely no relationship between the two languages. They're separate languages, and all we are concerned about is the use of JavaScript for us. So a quick note about the requirements for scripting. Scripting is supported only on the newer Vision systems that carry firmware version 5.1 and in the future higher versions. So today, the only Insight Vision systems that will support scripting are 5705, 5705 Color, or the 8405 Vision systems. So the older models, 5000 series, 7000 series, or the micros will not support scripting, and in fact, they cannot be upgraded to use JavaScript. If you hear demands from customers for older systems, please let the Insight Vision Systems marketing team know. At the moment, we do not have plans to allow older systems to actually support scripting. A word about target users for scripting. In general, we are looking to target advanced users of our tools who have some programming background. And they are the ones who will be the most excited about the scripting capabilities. So, for instance, these advanced users, they have been building complex jobs, and as a result, they have run into spreadsheet cell limitations. They might be running into limitations as to the number of cells that are available to them. They might be running into limitations as to the complexity of the formulas that they can create. And for that matter, they might have used scripting in other products. For other users who do not have programming background or have very little experience with programming, I would suggest moving with caution. They might be a good starting point. For them, it might be a good starting point to start in these general spreadsheet capabilities and only then move into the scripting area. And generally speaking, they will need some training and some support to achieve success. All right, so the question is, what problems is scripting really helping us to solve? So let's talk about a few challenging problems. And let me start by describing one for you. And this is the one you have seen before in other presentations, but really it highlights the problems with spreadsheets very nicely. Now, what we are trying to do is trying to locate and mark the missing blobs in a grid. Now, this is a small grid. I think it's a 13 by 18 grid. But still, without scripting available to me, what I would need to do is basically go out and lay out my tools row by row and literally for each entry in the row. And in the process, for this small grid, I will consume around 1700 cells. Now, if I want to expand my analysis in this example, you can well imagine the amount of effort needed to actually make sure, for one, that we have addressed the changes, and two, whether we have addressed the changes correctly. And as the complexity of analysis grows, you obviously see more problems creep up. Now, there are many other examples of challenging problems where spreadsheet actually runs into issues. For instance, handling dates and times in a flexible way, or setting up complex logic where you dynamically pick a pattern based on some sort of complex criteria. Or you might be trying to do string manipulation. Or you might be setting up some more complex calculations where dependencies between different variables is just hard to keep track of. But there are certain common features among all of these, and there are a few characteristics that underlie all of them. So there are three things. First is the wasted cell space. Now, repetitive inspections just require many cells. And as we saw in the example of marking missing blobs, we were basically laying down vision tools row by row, column by column. In the end, we used up nearly 1700 cells for what was essentially the same thing over and over again. The second is writing spreadsheet formulas that are even moderately complex is just a pain. And I'm sure many of you have tried handling dates, basically accounting for overflows or handling invalid dates such as February 31st. It just is hard. The challenge there is twofold. Expressing the logic itself, because either you don't have the formulas or the functions needed to handle them, or you need to set up cells for every little thing. And then how do you manage it? Because we use cell references to create formulas, there are no names associated that we can actually use in the spreadsheet. Now, all of this basically leads to the pain of debugging and maintaining large, complex job files. Now, imagine trying to parse through crazy dependency trees like the one you see here on the right. And some of you might recognize this as the track and trace job. But it's just incredibly hard as you build really large and complex job files. So what does scripting give us? Now, very quickly, there are three things, and I'll go over these separately in a minute. First, it helps reduce clutter in the spreadsheet. You essentially compress or basically compact the logic that would be spread across multiple cells into a single cell. Second, you have access to a really powerful JavaScript language. You can program really complex logic and calculations in this language, and all of this, again, comes in a single cell. And last but not the least, you get the benefit of a very powerful mechanism for building and protecting IP. So let me go over these one by one. So let's talk about scripting reducing spreadsheet clutter. So earlier I showed you this example of trying to mark missing blobs in a matrix. And I claimed that it would take nearly 1700 cells if we went by a purely spreadsheet approach. Now with a script, I can actually compress that entire logic down to a single cell. That is literally 1700 times space saving. My entire spreadsheet solution with scripting, including comments, is about 15 cells. And look at what I can do with a single script cell. Not only did I identify the locations, I actually plotted the points on the image. These are the red crosshairs that you see. And I also marked my rectangular search grid. I can actually make sure that my search regions were actually correctly aligned with the blob positions. All of this I could achieve with a single script cell. So with the script cell, not only did I have vision logic, but I also built logic for plotting and graphics on the image. Let's talk about complex logic. As I had mentioned before, what you have at disposal is the powerful JavaScript language. It includes features for handling arrays, strings, date and time. You have also access to vision tools data, such as blob results or edges. You can in fact manipulate binary data within the scripts for communication. Scripting lets you iterate over results using looping. It can remember results between inspections. And of course, scripting gives you the power to build reasonably complex image graphics. You have access to, in fact, several of the Insight's image graphics functionality. So code reuse is an important benefit of using scripting. Now, when I say code reuse, it's, of course, copy and paste JavaScript across jobs. One can do that, of course. But for our advanced users, PSIs, machine builders, OEMs, they often spend tremendous amount of time building complex applications. For them, it is actually beneficial to create libraries that they can use across projects. So they can create, for example, JavaScript utilities or functions that are independent of the Insight job files for things they might do over and over again in many jobs. So once they have the libraries, they can call functions within these libraries any number of times by simply referencing it across multiple jobs. Of course, the libraries have to be saved on a camera, but again, once you have the libraries, you have your IP built up, you license it and protect it. As I said a second ago, script cells can contain fairly complex logic and therefore can contain really valuable IP for our partners and intellectual property that they would like to actually protect. So for them, all the Insight tools that we have today for protecting cells are easily applicable here as well. Basically, they can protect the script cells with the usual mechanisms available in Insight, the same password protection, the licensing and stuff. Now, the key benefit here is that instead of node locking or password protecting a whole bunch of cells across where their spreadsheet logic was contained, now they can basically say all that logic will be inside a script cell and we'll just protect one cell. So it's a much easier process and much more robust. Let's talk about some of the key scripting features. So users have access to JavaScript versions of several vision and binary data processing functions that you already have in Insight. In many cases, the syntax you will see in JavaScript resembles the syntax for spreadsheet functions. In fact, for example, in here, we are using the getEnfound function, which has very similar syntax in the JavaScript world as well. Similarly, many image graphics functions from the spreadsheet environment are also there in the scripting world. Again, like I said before, syntax is very similar to the spreadsheet functions. And finally, you of course have the full math, string, date processing capabilities of JavaScript as well. And this enables you to build really complex vision applications. Or, as in my case, if you have way too much free time on your hand, you can actually build a clock or try to trace the path of a point on a circle as it rolls along on a flat surface. Now, these two are interesting here because both of these were built using Insight scripting. I simply used an all-white image and I'm using the Insight functions to build these graphics. Among other features that are available for scripting, there is a full-fledged JavaScript editor that is available. You can basically the way you use it is you type in the script function, it launches this editor. Paste your script code into this editor. It comes with a built-in template. It's extensively documented, so you know exactly what each part of the script does. And it's a customizable template. So there is a special structure we follow for these scripts, but this is again very well documented both in the script editor and in the documentation as well. There are several shipping snippets and job samples that you can already access within Insight Explorer. And what I'll do next is I'll quickly walk through the 4 snippets that we are shipping today. The first snippet, it's a date processing and a string processing snippet. It basically checks if the date lies within a specified range. It takes a fixed string as an input and returns a true or false in form of a 0 or 1, which basically says, okay, whether the date is within the range specified by the user in form of those spinner controls. So the next snippet is simulating a shift register. The interesting part about this shift register is the ability to actually handle multiple kinds of data. Right now, it is set up to be to handle random numbers, but practically speaking, it can handle anything you throw at it. That is the flexibility that it provides. The next one shows you how you can handle variable number of inputs. So let's say you have a list of 10 numbers, but this is not necessarily confined to 10 numbers. It could grow to 12 numbers or 15 numbers. So the example basically tells you how you can actually handle this. It also shows how you can return multiple values by a single script. So in this case, it returns average, standard deviation, minimum, and maximum just using a single script. So the next snippet example is one we have talked about over and over again, detecting and marking locations of missing blobs. This is an interesting problem. The script you will see is reasonably complex and is very educational. And it gives you a sense of how complex it can be, and the reason why for even a simple setup like this, the number of cells you would use in a spreadsheet-only solution is such a large number. So in the example I mentioned, we use nearly 1,700 cells, but with scripting, you can reduce that logic to a very small number. In fact, the script cell is a single cell. The rest are setup cells. In fact, what we are doing here is not only just marking the missing blobs, but also marking the search grid. So in summary, what are the key takeaways? So we looked at 4 scripting benefits. The first was reducing clutter in the spreadsheet, basically by compacting the logic into a single cell. We looked at setting up complex logic and calculations, again inside a single cell, creating complex graphics using the inside image graphics functions. And finally, we looked at building and protecting IP through the use of libraries and protecting and licensing script cells. Among some of the key features and capabilities, we touched upon the vision data processing functions and image graphics functions, the JavaScript functionality, the editor and the built-in template that comes along with the editor and the script function. And finally, we looked at some of these snippets. So here are some of the resources that you can use for learning about JavaScript and scripting on Insight platforms. There is a Vision Systems Product Marketing SharePoint page that has a whole bunch of resources on scripting, as well as other topics related to Insight platforms. We also created an internal forum for JavaScript. Please use it for posting questions, sharing knowledge, tips and tricks, and any demo ideas that you have with the team. And finally, of course, you have the Insight marketing team, myself in Natick, Rob Robles and Samantha Frost in Portland, and John Keating, who's the director of Vision Systems Product Marketing Group over in Natick. So thank you for watching this video. I hope you found it useful and learned something.